So, so today's essential question is, what's a particular solution and how is it different than your general solution? And we looked at this graphically at the beginning of the unit. And so we're starting to look at this more analytically. In other words, using our algebra, using our calculus, not relying on graphs, not relying on calculators. So we know that in order to get a general solution, we have to separate our variables. And that is always a multiply and or divide process, okay? It's definitely a multiply by dx. You're gonna have to do that every time. And then you're either gonna have to multiply or divide by a y term or a grouping that contains a y term. That gets a little muddy, but you'll always have to multiply by dx, and then you'll have to just figure out the math. I'll help you through that for the other part. Finding the particular solution first involves finding the general solution. So you have to do everything you've been doing up until now. The particular solution is like the step added on to the end of the process. So if I pull this graph off of day 2, I think, right, here's our slope field. We can see a few horizontal asymptotes here, up here at what looks to be 6 or something like that, maybe. And then down here at the axis, definitely an asymptote, because I see a positive slope above and a negative slope below of about the same magnitude. So we have some symmetry there. And then, so the whole idea then is a general solution could be any family of curves up here, or any family of curves down here in the middle, or any family of curves underneath here. Those would all be general solutions, because basically that plus c on the end is just shifting everything either up or down for the particular solution. So if I want to go through a particular point, which is what we're focused on today, that means I have to have some sort of x and y coordinate that says, hey, what's the equation through the points 3, 2? Then I know I need to do a particular solution. It's nailing it down. It wants to go through this point here, which means I can't be up here above the horizontal asymptote. I have to be between them, okay? And so that means that I have to nail this down so that I can get a specific C. So for instance, like if I picked a particular solution through the intercept 0, 8, then I know my C would just be 8, because the C is the y-intercept. But if I wanted the particular solution down here through 3, 2, I would need an equation that has this as its particular solution, which means my C is going to be right here at this intercept location. I don't know where that is. Maybe it's like 0, 1/3 or 1/4 or something. I'm not sure where it is. But when I plug in 3, 2 into my general solution, I'll be able to find that C value algebraically. Okay, and that's the focus today, is that last step of substituting in that. We call this the initial condition, or IC, and that forces it to go through that point. So so we find that particular solution. To find that particular solution, we've got to first get the general, then we can get that initial condition. And just be careful to know your x's and your y's for the coordinate of the initial condition. And then there's just to kind of give an insight into kind of maybe a tricky question. Sometimes they'll say, hey, you have this differential equation dy dx equals something, and I want to know what f of 3 is. That is an indication. They're asking you to find a function value when x is equal to 3. That's an indication that you have to go through this whole process of general solution, substitute in an initial condition to find your C, write the particular solution, so get the C out, put the number in, and then use that and stick in an X value to find a Y value. Okay, so that's definitely a multi-step sort of thing. But whenever they ask, just, whenever they just, kind of randomly say, hey, find f of 3, and you know the differential equation, it's a huge multi-step process. So today is kind of me to help you navigate those sort of scenarios. Okay, so it's different. We know that a particular solution is the specific function. It's the solution function. It doesn't represent a family. It doesn't have a plus C. It's a specific function that we can graph and point to and say, yep, it goes through this point right here. We've got day 6 topic questions. I guess the other thing we can mention, it doesn't represent a family. It represents one function. We've got topic questions for day 6. Yes, day 6. We've got notes for day 7, and you have a quiz tomorrow. Okay, so I'll let you get working on that, and I'll be around to check in the notes.